Ceire Kenny works at Lendlease as a sustainable futures consultant and provides internal life cycle assessment and embodied carbon advice to the business and crucial decision-making stages. She is involved currently in numerous life cycle assessment projects across several building typologies, a variety of structural types, and in 4 different countries. She has completed a Bachelor of Science in Environmental Management and Chemistry from the University of New South Wales and has several years' experience in the industry. She is also a certified life cycle assessment practitioner on the Australian Life Cycle Assessment Society Registry. Please welcome Ceire.
Hi, everyone. It's great to see you all here today in person for a change, which is nice. Thank you for the introduction. As Jeff said, my name is Ceire. I work at Lendlease in the Sustainable Futures team, and I'm a life cycle assessment and embodied carbon specialist. And I'm also American. So I'm just going to say at the top of this presentation here, I'm going to be saying aluminum. All right. So there's a bit of translation for us. When I say aluminum, I mean aluminium. Okay. So I'd like to start off with acknowledging the traditional owners of which we're gathered here today, the Gadigal people of the Eora Nation here in beautiful Barangaroo. And as I said, I'm actually from the States, so I didn't know much about Aboriginal cultural heritage until I came over here 8 years ago. And one thing that continues to fascinate me is the connection that they have to the land and to the planet. So when we look at what we have to do for sustainability in the future, I think what we really need to do is look back to the past and unearth some of that traditional knowledge. So for those of you who aren't familiar with Lendlease, just wanted to give a little bit of context. So we're a large international company, and we work in development, investment management, construction, work over 4 different continents, and we've got over 13,000 employees. I think if you add up the subcontractors too, it's like 50,000 or something like that. And Sustainable Futures, the team that I work in, is an in-house technical experts providing life cycle assessment and embodied carbon advice. And we've been doing so and building up that capability internally over the last 10 years, which gives us a unique amount of benchmarking information and internal expertise, which is really exciting. Even more exciting is the targets that we recently announced. So Lendlease is a 1.5 degree aligned company, and we have set 2 very important climate targets. The first one is to be net zero, scope 1 and 2 by 2025, and to be absolute zero carbon, scope 1, 2, and 3 by 2040. Those are ambitious targets, and they should be, because we need to act like the planet depends on it. Now, one of the most difficult parts of this target for us is going to be our scope 3 emissions. The majority of our emissions as a company is our scope 3. And as we know, they're notoriously difficult to tackle, but not impossible. So it's really important for us to get to where we need to be by 2040. Those targets mean that we're going to have to change the way we build fundamentally. And what that looks like is changing the historic way that sustainability or life cycle assessment has normally been treated, which is pockets of excellence on particular projects in sustainability, to a combined bottom-up and top-down approach. So what those climate targets do at the top is set this big ambitious goal, and then that leads to these more detailed decarbonization roadmaps for all the businesses in the different regions. And then that leads to having strategic supply chain partnerships, making sure that our suppliers are actually going to be able to give us what we need in that timeline and come with us on that decarbonization journey. That then filters down to excellence in design guidelines and minimum sustainability standards, saying, hey, this is just the way that we're doing things now if we need to get to where we need to be by 2040. And then that leads to very specific, ambitious, and viable development briefs and project targets. And then eventually that filters down to the material specifications and supplies that our supply chain receives. So how are we actually going to measure our scope 3 emissions? Through the magic of LCA. That stands for life cycle assessment. And as an LCA practitioner, it's my favorite thing to talk about. So life cycle assessment, for those in the room who don't know, is the complete measure of a building's life cycle, from the raw material extraction, product manufacture, transport, construction, building operation, and end of life. And that is a really good measurement of a building's embodied carbon. But at the end of the day, that's all it is. It's a really good measure. The true power of LCA is leveraging that measure at key decision-making points and being able to help it drive decision-making. So here I have a sort of idealized version of what a project level engagement with life cycle assessment should look like. That life cycle assessment is not done once. It is done in an iterative manner again and again as decisions are being made. So the first would be opportunity and origination. So you're leveraging your stellar life cycle assessment benchmarks to help set really good, ambitious targets at the beginning. And helping inform major decisions that are happening at early concept design. So there are some decisions that happen really early on that are the most impactful to that project. Should the building be made out of, steel or reinforced concrete or timber? Should we have this sort of shading on the facade? What's the floor to wall ratio? All sorts of major decisions that are locked in early on that could stand to have life cycle assessment help inform them. So you have all the other considerations plus the LCA data layered on top. Then you go into procurement and subcontractor engagement. So that's where you're able to put suppliers next to each other and see how those different procurement choices can change the environmental impact of your building. And then at detailed design and as-built, you have a beautiful, perfect life cycle assessment that gives you all the information you need about the environmental impacts. And then that is going to go right back to the beginning to help inform opportunity origination. So why am I talking about this in an aluminum presentation? Besides spreading the good world of life cycle assessment, what it means is that this is going to be a really important way about how we make decisions. And one exciting thing that we've seen from our benchmarking and from our previous life cycle assessments is that there's a few materials that we need to focus on. Now, this graph here on the left is a breakdown of a building by material component, not works package. So for example, the steel that you see there, it's all the steel. Okay, so it is the reinforcement, the structural steel, the steel in access floors and wall partitions all over the building. There's lots of steel. There's lots of concrete as well, especially in Australian context. And the third cab off the rank is aluminum. All right, so the steel and concrete industries have been on this decarbonization journey for a little bit longer. And as an industry, they have aggressive reduction roadmaps that are already in motion. I'm not saying that they've solved everything, but I'm saying that they've had a little bit more progress. The next thing off the rank, and what I think a lot of people have forgotten about, aluminum. I think there might be somebody online. If you can mute your mic. Okay, anyways. So yeah, aluminum is important. And if you have a decarbonization strategy and you have a decarbonization roadmap, you need to start doing something about your aluminum. Where is my aluminum? Well, the majority of it is in your facade, is a short answer. There's some in other parts of the building, but the majority of it's in your facade. And the facade's made up of multiple components, but the biggest contributor to the emissions of a building's facade is by far its aluminum. And as we saw beforehand, that's due to the fact that it's industrial heat. It has to be heated up to really, really hot temperatures, and that's why it's so emissions intensive. Cool. So on to the case study, which is why we're here today. So the case study is One Sydney Harbour. It's the Waterman's Residencies. It is the third and final tower as part of the triplet of towers for triplet of luxury towers in One Sydney Harbour. It's in Barangaroo. This one is the smaller one out of the three towers. So it's only 30 stories. It's got 212 apartments. It's a Renzo Piano design and a Daniel Goldberg interior design, targeting 6-star Green Star, expecting a 2024 completion. And in order to achieve the architectural intent that Renzo Piano had, which was crystals, we couldn't exactly have that sort of very classic Renzo clear glass without having to come up with a few design decisions in order to get that. So it's got that beautiful crystal look on the outside, and the open cavity facade design allowed us to do a few things at once. It ensured that we had the look that we wanted. It had stellar operational energy performance, well above minimum standards. It allowed natural ventilation to the occupants on the inside, and also was still able to provide a thermal performance and occupant thermal performance. There's just all three of them together. Don't they look pretty? Sydney's gorgeous, man. Okay, that's just a quick picture of open cavity facade. If you were like me the first time I heard that and I was like, I have no idea what that looks like, that's what it looks like. It's got an outer layer, a motorized blind in the middle, and then an inner layer with a DGU hinge door. Cool. So One Sydney Harbour Tower 3 is an excellent case study. But it's not a perfect case study, because in a perfect case study, as I mentioned beforehand, life cycle assessment would have been involved much earlier in that concept design. So to give you some context, Barangaroo documentation started around 2010. I was still in high school. And the open cavity facade design decision came around about 2014, and life cycle assessment at that stage came in just after that. So a lot has changed since we've announced our Mission Zero targets and the way in which we incorporate life cycle assessment. So I'll say it's not a perfect case study because it wasn't informing the sort of architectural design at that stage, but that doesn't mean that we didn't get in pretty darn early as far as LCA practitioners are concerned. So we got in to do some early reduction roadmaps. And from there, we were able to set really clear initiatives for what we needed to do to get to our target. Every building in Barangaroo has a 20% embodied carbon reduction target, and you're sitting in one right now. We then did a market scan saying, okay, we have discovered from our early reduction roadmaps that facade is a vital part of our reduction pathway. Because of the open cavity facade, there's a little bit more aluminum in it than a normal facade, which means that it had to be one of the most important things that we included. So after that, we had done a market scan saying, well, what solutions are out there for us? And then, and this is the part that I'm most proud of, is the supplier engagement. I'm not going to lie to you and say it was an easy process. It was a very involved one. It was a long conversation. We started the supplier engagement well before Tower 1 had gone up. And then we finally were able to get that into delivery. That success is going to be for Tower 3. So a little bit more about all of this. So the first thing we wanted to do was be on the hunt for low embodied carbon aluminum. What's low embodied carbon aluminum? Well, it tackles the part of the process that has the most emissions. And as we said, that is at the smelter. So low embodied carbon aluminum either has high recycled content or uses renewable electricity. It's usually hydroelectricity. And the second biggest contributor to primary aluminum's emissions is the direct emissions from the consumption of the carbon cathode during electrolysis. So another way to get low embodied carbon aluminum is through an inert cathode that's not carbon-based. But we decided to focus on those that used either renewables or recycled content because that had the biggest impact. Now, in that market scan, one of the most important tools that I used was environmental product declarations. Now, if you don't know what EPDs are, be prepared to hear about them a lot more often, not just for aluminum, but across the industry, because they are like nutrition labels for environmental impacts. We know that when we pick up an EPD, that it's followed the same product category rules as everyone else, that it's third-party verified, and I can make an apples to apples comparison between products. So if you don't have one, go get one and see if your supply chain has one or is willing to go get one, because this is going to be an important part of market transparency and engaging with our supply chain. So there are some aluminum EPDs. I've got some examples up there at the moment, but more are needed. Cool. So the market scan. So one of the things that we did for Sydney Harbour, and we were very particular about, was making sure that we weren't just plucking some, I don't know, like a standard facade module out of a off-the-shelf lifecycle assessment tool. We spent the past 10 years building our own lifecycle assessment model from the ground up in a software called Gabby. And it means that we are in charge of all of the assumptions that go behind it. There's no black boxes. And what it allows us to do is make incredibly bespoke measurements and to model whatever we want. And this facade was unique. So we couldn't just go find a baseline somewhere. We had to go measure it for ourselves. So early on in tender conversations, we issued a returnable schedule to our potential suppliers saying this is going to be important to us and we need to get the exact material measurement of this facade. So the kilograms of aluminum, steel, glass, all the different materials for each individual facade module. It was an exercise, but it made our suppliers really keenly aware that this was important to us, and we were quite serious about finding reductions for this works package. That market scan allowed us to find that the reductions that we could see with those products was between 30 and 50%. And that EPD information allowed us to be able to see what ranges were available. And given the fact that if you're doing like a value engineering exercise or something, you're only going to be able to shave off a percent or two, a 30 to 50% reduction in your facade is huge. So this is the part I said I was the most proud of, and I'm not going to say that it was a straightforward process, but I think it was probably one of the most important things that we learned out of this. And yeah, just it was a really cool part. It was great to be involved in this process. So the first thing we did, as I said, was include the low embodied carbon requirements in the specifications early in tender conversations. And we'd already had these conversations for the first and second tower. So third time was a charm. And then we asked for that facade material data. And then after doing the market scan, we suggested some of the known low embodied carbon solutions that we had to our suppliers. And then we also found out that our UK counterparts, seems like the UK is ahead of us in a few things, and we could stand to find a few lessons learned from them. Our UK counterparts was actually successful in getting a low embodied carbon aluminum facade on their building. And then after inquiring about like what can we learn from this, it turns out that they were using the same facade subcontractor that we were using here, who also had a global presence. So like, okay, fantastic. Let's see if we can find the same, we can apply the same solution that you had to our project. It did not work, but that's okay. You know, in supplier engagement, there's going to be a few dead ends. So basically, the exact supply solution that they had was cost and program prohibitive in an Australian context. Not deterred, we decided, okay, let's refine our question. Instead of suggesting specific products, how about we reframe our questions and ask to see if that technology exists in the supply chain? Do you have any smelters in your supply chain that use renewable electricity or have high recycle content? And after, again, this really collaborative process where they went back and actually gained transparency in their own supply chain, we found that there was something already in their existing supply chain that used renewable electricity in one of their smelters. And it had an EPD and it was ASI certified. So it was all good. And we decided to go for an agreement of preferential sourcing from that smelter for this facade, and success. So 34% reduction is what we got out of this one. And I'm hoping that for facades in the future and for other products, we'll be able to get even more. So I'll just preface this by saying, the building's not built yet. So none of this is as built information. It's just what we're projecting at the moment. Okay, so big disclaimer there. But the overall reduction that we're getting out of the facade is a whopping 6% for A1 to A5, which is pretty big. And then the absolute reduction after including all of the embodied carbon reduction initiatives that we had. So 40% cement replacement, a portion of the reinforcing being electric arc furnace, and of course the low embodied carbon aluminum, we're hitting around about 17%. And then we also had, after maximizing the amount of reductions that we could get out of material procurement, we had a few carbon neutral reductions as well. So that included carbon neutral concrete in the tower, carbon neutral reinforcing in the tower and basement, carbon neutral construction, because Lendlease is a climate active certified carbon neutral service provider, carbon neutral construction provider, and carbon neutral key finishes. So like flooring and wall partitions, that sort of thing. So that's where we got overall. What were some of the challenges? There were many, okay? So, but that doesn't mean that it was impossible. So one of the first ones is facades are complicated and they have an incredibly complicated job to do. None of sustainability can operate in a vacuum. You have to include all of the subject matter experts and all the other considerations here. And you've got a lot of plates to spin and a lot of things to balance. And that's the way that it should be, really. It was a new conversation for our supply chain, a new conversation for us as well. There was lots of lessons learned about how you engage with supply chain, making it a collaborative exercise. The emission source is not in your direct control. So where the emissions are and where you are, there's like 3 or 4 layers in between. So it does make things more complicated and just means that's a longer conversation and requires some persistence. You're changing well-trodden paths. The supply chain routes have been going on the same way for decades. So that's never an easy thing if you're one of the first movers, but again, not impossible. And just we're a really risk-adverse industry in general. So doing anything new, there's lots of uncertainty and you're going to have to, you know, say like, it's okay, we're going to hold hands, we're going to get through this together. Some of the reasons for success on this particular project, the bespoke measurement, I think was absolutely huge, being able to get that really granular data and that returnable schedule. Specification language, again, we had 3 shots at it. We ended up with specification language that was ambitious and specific, but not prescriptive. So it was a GWP not to exceed value for the primary aluminum billet itself. Supplier engagement, as I said, persistence, clarity, and a collaborative sort of attitude about it. We found an opportunity within our supplier's existing supply chain. That's not always going to happen, but I think that definitely helped that they didn't have to have a whole new line to dot there in order to get a new supplier. In this particular instance, big old asterisk, the price premium on this material was not cost prohibitive, which is, I think, again, sustainability doesn't happen in a vacuum, and we were able to do this without a major cost to the program. And we leveraged precedent from our international counterparts. I think seeing that it had been done over there gave us a lot more certainty and sort of a place to go. So yay, it was great. Okay, so really quickly, some of the main lessons learned is that after this, this first, building out of the gate, doing this type of initiative, the conversation about low embodied carbon facades in the business has absolutely exploded. It's now included in multiple roadmaps. We're looking at doing it in other projects. It was a huge win for education in the supply chain. So the next time that they're asked about low embodied carbon aluminum, they're like, we're all over it. We know what to do. We understand why it's important to you. It also was a lot of work, guys. So it meant that we're keenly aware that this needs to be something that's included in our top-down conversations to make sure that this level of work and engagement isn't required on every single job, and that we make that a more streamlined BAU process. Also, the inclusion of life cycle assessment in early facade concept design, and just a lot of really important learnings about what it's going to take to get to our Scope 3 target. I'm not going to read through all of this for sake of time, and you're probably bored of listening to me. But these are just some, if we, for lessons learned for the next project, if we are looking at including life cycle assessment into some of these facade decisions, these are some of the ones that we would hit. So value engineering, you're doing that anyways from a cost saving perspective. So why not look at it with an additional lens of LCA as well? Kill two birds with one stone. Optimizing building and facade ratios, so wall to floor ratios, do parametric design, cladding zones, all those sorts of things, doing like a really thorough and quick agile analysis with LCA to help inform those. Circularity, not just looking at the building's embodied carbon, but what we're doing with that facade at end of life, and all sorts of other things. So that's it. If you walk away with anything, engage early, make the ask specific, clear, and built for collaboration. Persistence, just because you get no the first time doesn't mean that that's the final answer. And don't let what you can't do stop you from doing what you can. That's me.